Hey everyone. From today morning, we were listening to more of AI. So I'm not going to talk about much about AI, but we'll see like how do we leverage at the end if it really needed. So my topic is chaos engineering for performance resilience. So basically, how do you build a resilient systems, more of a fault tolerant systems? That's where we deep dive here. And our previous speaker, Walter, had set the stage by giving us the terms like observability, distributed system, and what if something has failed? If something has failed, how do you react? And what do you do next? Those are certain things we will look at. And yeah, this is about me. I work for Global Logic as a lead consultant. So I work with my clients to set up their QA practices, their test strategies, and we work with them to figure out their performance issues and setting up their performance test strategies. Similarly, the strategies for chaos engineering. So all that we take care as a team. So moving on, I know this is like almost end of the day, so I want to make my talk a little more realistic and like you can easily relate to the real world. So I hope all of you know like fire drill. It's like a boring activity. It's annoying, but it really save our lives. So what do we do in fire drill? Basically, we ask everyone to take up the stairs, and we educate them basically to go through the staircases. What is the evacuation plan? All that will let everybody know during the fire drill. So in case of real fire happens, people are ready for it. People are ready for the failure. So similarly, what is a kind of fire at our distributed applications? Any guesses? What is the real chaos in application development?
Probably down in production.
Yeah, what if something goes down? What if there is an outage? What if my critical service went down and it didn't respond? So we will be talking about what is the fire drill in IT. That's nothing but chaos engineering, where I'll be introducing the failure. I as a chaos engineer introducing the failures and like injecting the failures to the system, and I understand the system behavior and validate the system behavior. So basically, like if you go to the definition, it's a discipline of experimenting on a system in order to build confidence in the system's capability to withstand with the turbulent conditions in production. It's nothing but you are injecting the failures, you are understanding the system behavior, and you are making your system more resilient. And I guess most of you have heard about Chaos Monkey. This is something introduced by Netflix in 2012. So there was like when they moved from their monolithic to cloud environment, there was an outage. That's like their services went down for some time during the Christmas Eve. Then the Chaos Monkey concept has came into picture where they validate the resiliency of the application. But I won't be talking more about the Chaos Monkey tool today, but that is something like you can easily relate to. So in general, to talk about why is this important. So with the modern applications, our applications are more or less distributed in nature. They're quite complex. It even takes time to figure out if something goes wrong in production, because you need to relate lot many things. There are multiple microservices which are dependent on each other. So just like to give you a glimpse of why chaos engineering is important, we do our application development. We work for the applications like sometimes day and night. It's all because we need to ensure that customer experience is good. We need to see that we are making an impact in the business. So we will be looking at like when you look at business impact and customer experience, we see like what if like if there is a failure, what is the customer impact going to be, and how my core business functionality continue during chaotic conditions, and what parts of my system is more resilient and more critical in terms of user experience. So those are certain things we can validate in terms of business impact and customer experience, that's where your chaos engineering plays a role. Organizational readiness. So we know that failure can happen. If failure happens, is my team or my engineering teams prepared for it? And do the team really know how to fix the issues? Do the team know how to how to identify the failures and fix it? And then it's like it's basically the team's culture to prepare for the failures in a graceful way. So they should be able to handle the failure in a graceful way. So that's all, like that's where chaos engineering is more important. And another thing is, yeah, we have to make our systems more resilient and fault tolerant. So how does my system behave in terms of an outage? Is it not responding? Am I not able to complete the user paths end to end? I mean, the users are not able to complete the process. And what if there is a critical service that crashes? So is there an outage? If outage is there, then how much time and when I can revert back? When can I roll back? So these are like certain things you can get the answers with chaos engineering. Another one is recovery and incident. So this is where like we need to make our engineering teams more prepared. Like if something happens, something goes wrong in the production, how are you maintaining your playbooks? Are the SOPs up to date? If something doesn't work, do my DevOps and Ops teams knows how to fix the issue? So these and all, like you will understand in a better way once you conduct the chaos experiments. Any questions so far? No? So let me move on. So once the chaos engineering has been, now we got an understanding like why chaos engineering is important. But to conduct the chaos engineering, there are certain principles which are set by Netflix. So the principles are basically like you go to your application, you understand the steady state, define a steady state, and you hypothesize a scenario. If like during the steady state, this is how my system works. And if there is a failure, this is what I'm expecting. That means suppose you have your Kubernetes pods, if one or like two pods goes down, I might experience a high response time. That would be your hypothesis. Now, once you introduce the failure, you analyze the results. Once you analyze the results, you see if there is an improvement for resiliency. What if the response times are like too bad? What if the service is not up and running when you are like when you are bringing down your pods? What if when you bring down the pods, the pod is nothing but it's a microservice? I mean, most of the people who works in Kubernetes environment, they know. So if you bring down a pod, is it immediately spinning up? Do you see that your pod is coming up? So those are certain things you can validate. So this is like the basic principles that we need to follow when we are designing our strategy. So this is from the source of like principles of chaos engineering. There we have defined, there it is like all the principles are defined. So whichever tools you use for chaos engineering, ultimately they'll be using these principles in the back. I'll tell you one classic example here, like one of the example of chaos engineering where we can introduce a region outage. So the region outage is like, let's imagine I have two DR centers here. One is the DR1, another one is the disaster recovery 2. If one of the region or one of the availability zone goes down, how my application behaves. So this is one of the scenario that we can validate. So for each region, we have two availability zones. Usually it could be 2 or 3, it depends. It depends on like how resilient you want to make, your application. So it could be multiple regions. But yeah, what if one of the availability zone goes down? What if one region goes down? Am I able to distribute all my load into another DR cluster? Is it something we need to validate? So this is basically a simple configuration at the load balancer. We can do a configuration changes at load balancer, and it will direct all your load in terms of any disaster recovery. It will direct all your load to the other disaster recovery center. So this is one of the scenario that we can test it in chaos engineering. And like now this is like just an example of chaos engineering, one of the scenario, but there are like multiple things. It's not like a very few. There are like, you need to go much deeper into it if you want to really do the chaos testing. So how do you want to do in your real time when you are working in an application? If you want to start with chaos testing, how you can start off with the chaos testing? So my suggestion is like, you start small. So start small in the sense, first start with a simple experiment so that you can contain your failure. You need to contain your failure. You should not increase the blast radius when you are introducing the failure. That means, suppose if I am introducing a failure at microservice 1, it shouldn't impact my another 10 microservices. So that's the first step you need to do. And when you are introducing a failure, just introduce at one availability zone. If you have 3, try with 1. Than trying at a region altogether. So that's how it would be easier to go. And to make our understanding more clear, I'm going with an e-commerce application, since most of us are familiar with like the general e-commerce, the top e-commerce vendors that we have, like Amazon, Walmart, whatever you can think of. So this is this is one of the e-commerce application I can see here, and this is an based on architecture. This is like an event-driven architecture that has been developed in Azure. So all my microservices have been deployed in Azure Kubernetes, and I'm also using a Cosmos DB for each of the microservice, and I do have a Azure Service Bus. So that's on the Kubernetes side, and the other side, it could be like you can see the web UI on your left side. But before web UI, maybe you may have some legacy systems that you interact with. So the web UI interact with the legacy systems, and these legacy systems will interact with the microservices on your Kubernetes. So that's how the architecture looks like. So in this architecture, can anyone suggest me like what and all chaos conditions that I can try?
You could bring down a single database.
Okay. Any other? Yeah. Yeah, service bus, I have one classic incident. It happened yesterday in our production. So even today morning when I'm rushing to this conference, there is still testing going on. I'll explain it later. So yeah, there are like multiple experiments that you can conduct here. It could be your node failure, region failure. You can even inject the latencies here. And resource exhaustion, that is nothing but you can use your CPU and memory attacks. You make sure that your microservice CPU is going almost 100%, and memory, like you are exhausting your memory. So those are certain conditions. You can go with single pod, multi-pod failure, and even the dependency failures. And you can even do like scaling, fail scaling. That means even though you set your HPA, horizontal pod scaling, maybe it might not scale up properly. What is the condition you kept there? Is it like usually the scaling happens in like two, 3 different ways. One is like, if the CPU reaches 75% for all the pods, then it could be, then additional pod will spin up. Or else if the memory reaches 75% or 80%, additional pod will get spin up. Sometimes we even take both of these conditions together and then set the HPA. That is nothing but horizontal pod scaling. We do have vertical pod scaling, but that's again like, we'll do it when we are conducting the performance engineering itself. So certain chaotic conditions that I can introduce here is like, one is the latency. So if you see in this architecture, the payment service is the third party application. So we don't have really control on the third party. Sometimes our third party applications might be much slower, or they might go unresponsive. Then how do you handle those scenarios? If it is slower, what is the timeout you are setting? So what is the minimum timeout you are setting? And what are the retry mechanisms that you are trying? So retry mechanisms itself is altogether a different topic, like how are you going to set that? Is it exponentially you are increasing the retries? Are you adding any jitter there? So all of those conditions will come here when we go with the latency. So in my experience, how do we do is like, if I want to introduce the latency, I look at the production logs and see like how my service is responding. Based on that, we collect the metrics like 95% of min, max and average. We collect those metrics, and those metrics will take it into our, anyway it's a third party, so I can't have it directly, I can't test directly the third party. So I'll be having a virtual service for that. So that virtual service will introduce different latency settings, and I validate how my application response time is varying end to end. So there is one more criteria that you may need to test is like when you introduce the latency, definitely the third party is taking more time means the service bus where you are adding up your messages, that will pile up a lot. When the service bus messages pile up a lot, if you see a large pile up like 1 million messages or like 500k messages, then automatically the response times go down. So that really impacts your business. So all of these, like you need to try with multiple different conditions with the different strategies and then validate. So this is one of the scenario. And the other one is like imagine like there are 3 or 4 pods that I'm running for each of the microservice. I'm bringing down certain pods and then I'm validating how my application responds. And we do also validate like the node draining scenarios. So how do I bring down the node in Kubernetes? It's basically like you can go to your kubectl commands and then you drain the node. Once you drain the node, automatically the pods which are there in that particular node will have to spin up in the next additional node. So those scenarios we will be validating. During these scenarios, you shouldn't see any downtime in your application. If your auto scaling and the nodes have been configured in a right way, you should not be seeing a downtime, but you might see a little high response times. So that's where you hypothesize. If the node is down, I'll be expecting a response time like currently my microservice is responding at 300 milliseconds. It might go up to 400 milliseconds or 350 milliseconds. So that's how we validate. Another one is like in any of the application you might have certain services which are more critical, certain services which are not really critical. So here if you look at all of the services like the product search, shopping cart, inventory, order processing, shipping service. So when you look at all of these, I could see one that is non-critical, that's the recommendations one. So whenever you search through Amazon, like you look at the products and you see the recommendations. Though the recommendations won't come, if it doesn't come also, user should be able to check out whatever he is looking for, that particular product, he can successfully check out and place an order. So this is one of the service, we can validate, we can bring it down completely. There are no instances of recommendation services are running, but still like the user should be able to complete the transactions end to end. So all this testing, we do it at a steady state. That means, suppose if you look at any e-commerce application today, imagine like anything like Target, and if you expect a TPS of around 500 TPS in an average day, so you will be running a test for 500 TPS. During that, you will be validating all these scenarios. But it shouldn't be at a peak load, like if you were thinking of doing at a stress testing or like another different testing that you do, it's not really needed. So we can just go with the steady state and then we validate all of these. So in the back end, you will be running the test through your JMeter, load runner, whatever is the tool that you are using. So any questions here?
I'm not super familiar with gas testing, but it seems like kind of difficult to be able to simulate that steady state without testing in your prod environment. Do you like make some sort of pre-prod that's specific for the gas testing so that like the development work isn't impacting it and it's also not prod?
Yeah, so we do have a pre-production environment that's a replica of production environment. So whatever we see in the Kubernetes, that would be exact replica of the production. So we can play around there. But even chaos testing is like recommended by Netflix. It is recommended to play around in production environment, but in prod, but it is risky. So at least you need to experiment in your pre-prod You make sure that all the results and hypotheses that you are making is right. Then you can play around production, that too in a small, you take the smaller steps. So that would be easier. At least you need to make sure that the environment is equal. So what we do is like our environment is a mix of a legacy world and the cloud environment. So whatever we see on the cloud, that we make a replica of production. But what we have in the legacy, that would be like a 50% or 70% of the environment. So it is like, in production you have 8 nodes, in performance environment we have 6 nodes. So that's how we manage. But yeah, those servers still they are capable of handling.
Do you use like shallow traffic from the production environment into your other KS environment or something like that, or do you use synthetic transactions in order to load for your KS?
It's all the synthetic transactions. Anyway, we will be simulating the load. We have all the automation scripts that would be running and simulating the traffic. But we do a closer look at production issues and the production environment, because always the performance engineering team will be working very closely with the runops team. So in case if something goes wrong, then we should be like, we should ensure that that hasn't been tested or tested, all those conditions that I need to evaluate. So one of the situation that we experienced yesterday is like, in my production environment, the service bus has been piled up to 200K messages. All my pods are not even 50% utilized. So there is a lot of CPU by each pod under a microservice, but they are not consuming the messages. So the real problem was like, there is a concurrent sessions that we open from each microservice with the service bus topic. So based on the microservice capacity and based on the topics, the messages that we are sending to the topic, we open the concurrent sessions. So what happened is like, there was a simple miss. The topic name was not right in the prod environment. So though production has made sure that we opened 30 sessions, my application.yaml, my application code has been considered only 5 sessions. So even though you were running 6 pods, it's only 5 sessions are opened for the service bus topic. So your pod is underutilized, but your service bus messages are not consumed. So now my team is working on to fine tune the right number. So what we do is like, we usually play around with these parameters, we fine tune and we validate that each of the pod, even if you scale up vertically, it has to be at least 80%, 75% to 80% of CPU utilization. It shouldn't be like, since cloud has come up with all the auto scaling, you shouldn't be spending so much by enabling the auto scaling. So we just need to ensure that vertically the pod scaling works fine, then you go with the horizontal pod scaling. So that's what we are working on currently, and that's one of the classic scenario of chaos testing. So let's move on. Yeah, as I said, chaos engineering is a powerful practice. If you just do the things randomly, you get more risk. It would be more risky and it is going to be more inefficient. So how do I do this in a structured way? So for this, I'm going to introduce FMEA, that is failure mode effects analysis. So this is basically we follow in even all our traditional engineering model. So this is how we evaluate the risk. What if something goes wrong? What if there is a failure? What is the effect? What is the analysis that I can do? So how do I improvise my application? How do I improve my application for resiliency? So for that, I'm proposing FMEA, and this is what we use like in our practice. So basically this is where it takes a lot of time to work with your architects, engineering team, and even the DevOps, runops, like it's all the teams together. We sit together and we understand, we come up with this matrix. So once we are at this stage, then it is good to start chaos engineering. So I have given 3 indicators here, like severity, occurrence and detection. So our risk priority number is nothing but severity times occurrence times detection. So severity is like how serious it is going to be. If something fails, how serious it is going to be. Occurrence, how common it is going to occur in production environment. How common we might run into these issues. And detection is like how unlikely, how is that going to be undetected. This is basically the detection, I can say, if you have the observability, if you have a good observability on your systems, your detection rate would be low. If you don't have the observability, then yeah, detection, it may go undetected and it might cost you so much. So there are certain examples here. I think this is not showing up right. How do I
I wish we could do something, but then other folks are there.
Okay.
Sorry.
Yeah. Okay, then I'll read on this side whatever is on the left. So basically, how do you simulate if you simulate a region failure, what would be the effect of the failure? You see the downtime in your application. It could have, it might create a global impact. So how do you mitigate this? To mitigate this, you should have your DR clusters up and running, and you should have your global traffic manager, like it could be whatever the load balancer you are using, it would be GTM or FI load balancer. You need to ensure that your DR clusters have been configured well and it is routing the traffic when there is a region outage. Similarly, what if there is an improper failover setup? As I said, just a simple configuration might cost you so much. So if you didn't configure right, it might turn into an outage. So you need to test your configurations, whatever you do. So here we basically do two kinds of testing for region outage. One is high availability and disaster recovery, where we validate the disaster recovery servers are picking up the load and they are up and running in case of an outage. And the other one is we do also have an active setup, where 5% of load goes to one cluster and 95% of the load goes to another cluster. And is the percentage distribution working fine, as accurate? So those are certain things we need to validate. And again, another one, as I explained you earlier, this is availability zone, simulating a failure at availability zone. For this also, you can, these numbers, whatever I kept, this is I just put it for your understanding. Maybe it may not be exactly accurate, but it depends on the kind of application you are dealing with. Any questions here?
How do you determine the number of occurrences, in terms of scale of one?
That's basically if your application is already there in production, maybe you can look at the historical issues that you see. Otherwise, in general, how likely it is going to be. So region outage is it's something, natural disaster is something you can't really, you can't do it. You can't really understand that. But other things like improper failover setup, this could be very low. If you have if your configuration is right and you have tested right, then it could be low. So that's how it is. So moving on, I want to take you through a few more examples like node failure. As I said, node draining. We need to, in node draining scenario, what would be the mitigation strategy? If suppose a node goes down, you need to ensure that you have the anti-powered affinity and auto scaling. Anti-affinity is nothing but I want to make sure if one microservice, if I'm deploying one microservice, it has to be distributed across multiple nodes. It shouldn't be at a single node. So that way you are avoiding a single point of failure here. So if node 1 goes down, my microservice is already running in all other 5 nodes which can pick up the load. Similarly, the crash loop backoff, I think whoever working on Kubernetes environment, they knows this. Crash loop backoff is something we frequently run into. Even a small change in the entry point configuration will make you keep restarting the pods. So that's where the mitigation strategy is you need to go and validate the restart count and how is your liveness and readiness probes. So all these should be configured. So usually we have all this configuration in production, but you are working in pre-production environment, you should have all the similar configurations there too. So liveness and readiness probes should be up and running, and you should have the alerts and restart. Similarly, HPA, yeah, sometimes with HPA also fails. And there is another thing, in HPA also there is a setup, like when the pods are scaling automatically. Suppose if I am running 6 pods, minimum as 6 and maximum as 10, and when I run my test, at one point of time I see 75% has been utilized by all the 6 pods. Then there is a certain wait time will be there at Kubernetes settings. So it could be like, it might wait for 5 minutes. If they see a consistency of 5 minutes of 75%, then only it will spin up the additional pod. But sometimes we can't really wait for 5 minutes. So even those settings we need to tune a bit based on the application. Even right now what we have is like 5 minutes of interval. But ours is 5 minutes of interval, we are able to, just that we see some high response time. Other than that, it doesn't cause much issues here. And yeah, misrouting traffic and latency. Latency is like, we do this with lot of permutations and combinations to validate the third party applications. If they are not responding right, are we handling all those scenarios? So that we need to validate, because you don't have a control really on the third party applications. So now I think you got a glimpse of what is chaos engineering, why is this important, how do you do this, how do you do this in the distributed application architecture. Now at the end, if you are doing something, definitely as a quality engineer you have to show some metrics. So what are the metrics you can showcase to your leadership, or like the senior management, or even to the team on the chaos engineering? So the first thing is like, whenever some failure happens, what is the time it has taken to detect? Sometimes it may take time even to detect the failure, that itself is a big thing. And then how much time it takes to recover for the failure. So these are like the two main metrics that we need to look at. And these metrics, basically when you create your FMEA matrix, when you create your chaos engineering strategy, you need to have this defined. So suppose if there is an architect who is who developed the, who designed the architecture, who is like giving you these numbers, you need to validate, is this the same? Is this the same it is happening when you introduce the chaotic conditions? So that is something needed. And the error rate, yeah, when there is a downtime, you see error rate, because what I explained you the earlier scenarios where I'll be bringing down couple of pods, out of 6, two were brought down. In that case, I see the errors. There are errors coming like 503 service unavailable, but those transactions has to retry and they have to be successful. You should not see anything like, you should not see a transaction loss when there is like you are bringing down the pods, you are bringing down the node, you should not see a transaction loss, much transaction loss here. If you are seeing, then that itself has to be documented, how much you might see. So that's the other thing. And yeah, in performance engineering, the response time, the availability, scalability metrics is always we count for. So you need to look at all those metrics. And finally, like once you conduct the experiment, you need to see and validate how is my success rate, my experiment success rate. Am I able to cover the hypothesis right? Did I assume right? Whatever I documented, is that right? Something you need to validate. And another one of the key learning from chaos engineering is like, once you conduct all these experiments, you can update your SOPs and playbooks so that in real time, if a failure comes, our teams are well prepared for the rollback, so that you are reducing your blast radius, so that it doesn't impact much. So that's the other thing that you need to look at. And yeah, another key is like observability and detection metrics. So sometimes we do get alerts, but if it is a false alert, then that's like not right. So you need to also validate your observability alerts. And business impact. Finally, we need to ensure there is no business impact in terms of a failure. So how are you doing that? What is the revenue impact? And how many customer support tickets that you are seeing? So all of those will be your metrics in chaos engineering. And as I said, the multiple tools that are coming in. So first one is the Chaos Monkey, but that's a open source framework. Now we have Chaos Monkey, Gremlin, Litmus, StudyBit, Azure Chaos Studios. But all these tools are okay as long as you know the approach. It could be like how do you do the things in an easier way. And the real challenges is like, first thing is the resistance, organizational resistance. When something is working fine, why do I need to break it? And that's where you need to educate your team. And then lack of observability. If you can't see what you can't really measure anything. And the risk of real damage. Sometimes the chaos that you are introducing might turn into real chaos. So that you need to be careful. So start small, contain your experiment so that you are good there. And tooling complexity, multiple tools, just that your strategy is more important. There is not like whatever the tool that you use. And lack of measurable outcomes. If you were once you do the experiment, if you can't measure it right, then that would be a real problem. And yeah, at the end, there is a maturity model, and there is a question for all of you. Like, need to think where your organization fit here in this maturity model. So this maturity model is basically like, are you at a stage of unaware, ad hoc, or exploratory, structured, automated and integrated, business aligned, self-healing and predictive. The last one is like where there is a scope for AI. So now these chaos engineering tools are coming up with AI features where like the failures are more of AI driven. And our organization is somewhere here, the business aligned, but we don't have it automated yet. We are doing all the experiments manual. So anybody would like to share their experiences at your organization?
So, as you were talking about that, first issue you put in there was the fire drill, the staircase. One thing I think where we fail a lot is what happens if the fire starts in the staircase. How do you get out?
Yeah.
And we actually experienced that in real life. I used to work for Providence. Providence depends on Epic, which is the data system. Depends on Azure, which is the Microsoft system. And multiple times a month, we would have failure of one of the external system and no control over it. How do you simulate and prepare for chaos when the external dependencies are the ones that are failing the most?
So this is for the data systems. Are you talking about the data storage or?
Yeah, the data storage where all the data is that powers the system.
Okay. So basically, I mean, nowadays, the data system that you use, like Cosmos and all, they are coming up with 99.99% availability, where you can still like, they promise you. But the real problem happens, then definitely, you can't have all the data, the partition data, can't be completely copied to your another replica. So there, you might see some latency there. That is something we can't really avoid.
Right, the point I'm making though is not that. The point I'm making is you don't have no control what happens because it's completely company external to you.
Company?
So the company that provides the data storage is external to you. You don't have and you can control where the data goes. They are the only ones that have that control.
They are the only ones they have the control.
Yeah.
Ah, okay. Then that is something.
That's the staircase, Bernie.
Yeah. Then that is something we need to try on the other side, data source system side.
Yeah.
We have to educate them and do the things right.
Okay.
Yeah. I know. I mean, though we do all this testing, there are some. Yeah. Sometimes we do get into these situations.
Yeah.
Yeah, it's the same thing. I mean, I was talking about one incident. Even though we test, so it happened.
So one other scenario that came to mind, I haven't seen it, but what happens when your measuring equipment, your monitoring system actually fails?
Yeah. So for that,
and you have a false failure.
It's
the system is working, but you think it's not.
Oh, false failure. False failure is something we even need to think through. But yeah, we do have these, but we do have a backup. We do have another cluster where we have like two clusters we are having. So that's where it acts as a disaster recovery if something fails. But if it is a false failure, maybe yeah, that I need to think through, right? This is another problem. The false failure usually sometimes it comes. That's the reason even we need to do the testing on the way we are setting up the alerts. So sometimes in performance engineering itself, we do take care of all these. But at times the timelines are like too hectic. The team is like, just you need to complete the testing and give us the sign off. We want to go to production. So that's how the teams push us.
Right, absolutely.
Yeah, so sometimes we don't get time to do the exhaustive testing. Any other questions?
I think the place that I work is probably at level 0.
Okay.
Have PII and PHI in our system and no like environment that's reflective of prod. But we did just figure out how to serve a static page that says to the user, you're experiencing an outage. And it's like a lambda that serves that static page. So at least we can put that up if we're like having total outage. So it's not like whatever browser message you see that says
Hmm.
there's a site or something. But yeah, otherwise I would say we're 0.
Oh, well, it's 0. Yeah. Yeah, we do deal with the healthcare data, but yeah, we mock all those data systems and everything. So that itself is like another thing. Like you need to prepare a test data in such a way it is more of a realistic. I think we have many talks in the morning where they were talking about the test data too. So that again plays a role. I've seen sometimes in performance engineering we just go with the virtual services, create the data. That's not the real time. So it happened that one of the query is returning 700k records. When it returns 700k records, definitely it goes out of memory. My pod is continuously restarting. Whenever I trigger the load test, it restarts. So that's how it is, because even the performance engineering team will not get enough time to understand the entire functional aspects and the data aspects. But actually, even the performance engineering team should understand the business and data. Then only things go right. Yeah.
Sumalatha, you talked about the hybrid systems, right? You are on premises, some services are on premises, some are on cloud. So this chaos, as far as I know, like I work on mostly on cloud services. I was interested in how on premises is your
On premises, basically what do I test is like how I have 2 data centers in on premise. Like one is the east and one is the central. So we do have a load balancer. So the load balancer configuration we test. How does it goes? Okay. And when we do the performance testing itself, we do go and validate by each node. In one data center we have 3 nodes. How the load is getting distributed. So all those parameters we validate. That's one way of testing. And another one is like at each node you have the threads, the configurations. So what if I'm assigning a thread pool of like 1600 maximum, 160 minimum, then during the test how is it going to be? When threads are getting exhausted, how it is going to be? So all these configurations we can test even on the on-premise too. Yeah. But bringing down also you can do when you have the 2 data centers and the like disaster recovery part you can test. And sometimes it happens that in our testing one or the other faulty node will be there that would be causing high response time to your application end to end. So sometimes we have to go and work with this load balancer team and make sure that one particular node is down, and then we test it so that we can compare the response time metrics. So with the on-premise, these are like issues we get into most often.
So yeah, we are right about time there. Any additional questions?
Last question.
Oh, sure.
What's the recommended tool from your experience? I know like we have shown like some good tools there.
Yeah, I can't promote any tools, but yeah, I was looking through Gremlin. Gremlin is good, where they have a lot of options to attack, and it is more of a user interface is very easy to simulate the attacks. You go to CPU attack, memory attack, that would be more easier. They just run one process in the background, they ensure that your CPU is spiked up to 100. So that's how they simulate the CPU and memory attacks. So that is one good, and whoever is working on the Azure platform, they can use Azure Chaos Studios. But even I work on Azure, but we don't have Azure Chaos Studios license. So what we do is like we go on basically the kubectl commands, the manual commands, and then we validate. So that's how it is. But Gremlin is something I explored and it is good. And Chaos Monkey, they have a lot of variations in Chaos Monkey too. Chaos Gorilla, Chaos Simian Army, there are a lot many, yeah. We can even try that. It's an open source one. Yeah.
So in our org we had Spinnaker, like Netflix Spinnaker open source, then Kong and this combination.
Oh, okay. So you use that. So you try all the scenarios
Yeah,
through
yeah,
the tool.
yeah.
Okay.
Yeah.
Mhm.
So thank you, Suma, for showing us how structured research is actually